Okay, quick one. Hello. My name is Lukman Mohammed, a co-founder of the Science Hub Academy, where I take on physics. My partner is Mr. Ismail Salau, who takes chemistry. Now, let's see the test for our physics for first week. First question here says, which of these is a derived quantity? We know that derived quantities are quantities derived from the fundamental quantity. So when a quantity is not fundamental, it is derived. And fundamental quantities are also known as base quantities. So we are going to check from these options the option that is actually a derived. So a quantity that is not derived quantity is fundamental, and that which is not fundamental is automatically derived. So the units of fundamental quantities are also known as derived units or base unit. So mass is fundamental with unit kilogram, length in meters, time in seconds, electric current in amperes, absolute temperature in Kelvin, not degree Kelvin. Only Fahrenheit and Celsius take degrees Kelvin, degrees Celsius, and degrees Fahrenheit, but nothing like degrees Kelvin. Amount of substance in mole with units mole, okay, and then luminous intensity in candela. So the option here, kilogram is the unit of mass, that is base unit. Meter is the unit of length, that is fundamental or base unit. Newton, if you are confused, go to the last option. Seconds, that's unit of time, that's fundamental. So the correct option here is C. And then question 2 says, which of these is not a fundamental quantities? Okay, temperature is a fundamental quantity, it exists here. Okay, length is fundamental. Velocity, for confusion, go to the last option as well. Time is fundamental, so velocity is the quantity here that is not fundamental. And here this one says, which of the following pairs constitute only derived quantities? Okay, so we want to see two derived units, I beg your pardon. So derived units, Newton is derived, meter is fundamental. It's a unit of length, and that is a fundamental unit. So we want to see two combination that are both derived. Meter per second, that is a derived quantity. Meter squared, product of two fundamental quantity is no longer fundamental. So meter squared means multiplication of meters by another meter. That means you are multiplying two lengths together to get the fundamental quantities. So you have to multiply the unit of length twice to get the derived unit. So this is derived. This is equally derived. So let's check. We have seen our answer, but let's check through. Kelvin is fundamental. Meter is fundamental. This is a pair of fundamental quantities. Newton meter, that is derived, but kilogram is not derived. Well, our answer is option B. This one says, given that the dimensions for density is m to the power a, l to the power b, what is a plus b divided by 2? We are going to work this out. What is density? Density is the ratio between mass of a substance, okay, to the volume of the substance. So that is kilogram per cubic meters. What is the dimension for m? That is mass, okay, that is m. The derivation for volume is the product of three lengths, so it's going to be l to the power 3. So it can be in this format, or we bring the l to the power 3 to the numerator as well. This is m to the power 1, l to the power negative 3 from indices. So to compute this a plus b, what is a, what is b? So a, this is a is 1, and then b is negative 3. If we have look at the way they left it as a product, m multiplied by l. If they have left it as a quotient, m divided by l, it will have been m to the power 1, okay, which is a is 1 and l is going to be positive 3. But they have brought it this way, so a is negative 3. So a plus b, what is b? B is negative 3, in bracket negative 3, okay, and everything divided by 2. So this is, sorry, a is what? 1. I'm going to erase that. A is 1 minus 3. 1 minus 3, that is going to be negative 2 divided by another 2, that is going to be negative 1. So the correct option here is option A. Let's go. Question 5 says, one of the following is an application of dimensional analysis. Dimensional analysis has two basic applications. One is to check the correctness of equation. If you see equation, for example, v equals to u plus at, those if those terms if those terms v, u, and then at have the same dimensions, then the equation is dimensionally correct. So we use dimensional analysis to check whether equations are correct. We also use it to derive equation if you know the condition of dependence. So option A here says to know whether a quantity is fundamental, no. To know whether a quantity is derived, no. To show whether an equation is correct or not, that's the correct option. What's this saying? To show whether an equation we solve, no. So question C says, which of the following is a dimension for pressure? Let us see what the dimension for pressure. Let's work it out. Pressure is weight or force divided by area. Okay, and then what is force? Force is the product of mass and acceleration. So divided by what dimension for area? Area is the product of two lengths, that is L to the power 2. So what is force? Force is ma. Dimension for mass is m. Dimension for acceleration is lt to the power -2. We have taught us this before. So divided by another L to the power 2. So this is L to the power 1. So I'm going to use indices to combine the L's. This is m L to the power 1 minus 2. That is -1. T to the power -2. So which option has this? M L to the power -1, T to the power -2. This is option 1. Option A, I beg your pardon. Okay, let's go for question 7. At what respective values of x, y, and z would the unit of force, which is the Newton, be dimensionally equivalent to m to the power x, L to the power y, L to the power z? Let's work this dimension out as well. What is force? We saw it the other time that this is ma. Okay, so this is m. That is dimension for acceleration. I'm going to put x there. Okay, that is 1. M to the power 1. Let me erase this. I do not need x. I do not need the x anymore. Okay, so I need m to the power L to the power what as well? L to the power 1. So t to the power -2. This is acceleration. This is mass. So what is the powers of m, l, and t? M takes the power of 1, as can be seen. L takes the power of 1, and t takes the power -2. 1, 1, -2. That is option B. Option B is correct. Okay. The next question says, what quantity has this dimension from these options? Which one? Okay, let's see if I can break this into part. Force, we have seen that is m, mass, times acceleration, L to the power negative L, and then t to the power -2. This is m L t to the power -1. So that momentum is mass times velocity. Momentum of a particle is the product of the mass of the body and its velocity. So what is the dimension for mass? Capital M. Velocity, displacement over time, that is L over time, t -1. Is that the correct option? M L t to the power -1. Option okay, that is momentum. Option B is correct. Let's see. Well, we do not need to check the remaining one. For if we want to see that for acceleration, lt to the power -2. The dimension above has m. Density, mass over volume, mass, and then volume is L to the power 3. I'm writing it beside, it's going to be L raised to the power -3. Option B is correct, as we mentioned earlier. 9 says, in the relation s equals ut plus half at squared. This is one of the equations of motion. So the number 1/2 is regarded as what? Numbers do not have dimension, so they are known as dimensionless constants. Dimensionless constant. Option C is correct for that. And let's see this. Power is defined as work done or energy expended divided by time. Let's put down the definition. Power is energy or work divided by time. Energy or work, we can also define it as so divided by time. Work divided by time. What is work? Force multiply by distance. Okay, distance divided by time. What's the dimension for force? MA, mass. A, LT to the power -2. Okay, distance above is also L, that's distance, then divided by time. This is dimension for time. Let's combine these two L's, and that's all. This is M, L to the power 1 plus 1, L to the power 2, and then there is T negative above and there is T positive. So if this T positive 1 goes up, it becomes another -1. So ML L squared T to the power -3. So which of the option has this? Option A, M1 L -1, no. M1 L positive 2 T raised to power -3. This is the correct option. Thank you for staying with me. Stay safe. Bye bye for now.